Okay, so another limit. This time we're taking the limit as x is approaching 0. In our numerator, we actually have a fraction. And first, that numerator, we have -1. That's over the quantity x plus 2. Okay, and then plus, so get outside of that fraction, and then we're going to have plus and then another fraction. And that other fraction is 1/2. So that's just our numerator. Our denominator of this main fraction is just x. So again, first thing I would do would go in and plug in direct substitution. And if we get a number, we're good. If we get 0 over 0 or infinity over infinity, which we won't at this point, we have to manipulate it and work with it to get some value or show it doesn't exist. I can see right away when I go in and plug in 0 in here, I'm going to get 0 in the denominator. And then here we'll have -1/2 plus 1/2, right? And so we get 0 in the numerator. So again, this doesn't help me. I have to go back in and change this. So if you have complex fractions, fractions within fractions, and you get this indeterminate form, try to get rid of the complex fractions. And so recall there's two different ways to get rid of the complex fraction. One way is order of operations. You'd have to combine the numerator as one fraction. And then we could do, remember, if you have a divided by b, let's say divided by c over d. Well, that's the same thing as writing as a over b divided by, this way, c over d. And recall, dividing by fractions, you take the first fraction times the reciprocal of the other fraction. So that's one method. To clear this fraction within the fraction. I actually think that's the harder method. To me, I think it's easier if we look at the LCD of the fractions within. So notice at this main fraction, where did that go? Okay, so what I was saying before my screen disappeared was another way to simplify these complex fractions is look at the fractions within the main fraction and find the LCD. And then we're going to multiply this by the fancy one, our LCD over the LCD. So looking at the fractions within here, I notice I have one fraction, which is -1 over x plus 2, and I notice I have 1/2. And so the LCD for both of those, least common denominator, well, none of those have factors that are common, so we have to have both pieces. We need the x plus 2, and we need times 2. Doesn't matter the order I wrote that in. Normally, I would probably write this as 2 times the quantity x plus 2. Okay, so we're going to take our limit. And I have -1 all over x plus 2 plus 1/2 all over x. And now we're going to multiply this by our fancy one. And that fancy one again is that 2 all times x plus 2. 2 all times x plus 2. So notice when we distribute our LCD to each fraction in the numerator, our denominators go away. And the whole point of multiplying by that LCD was so we could clear those fractions. And we chose something that would do that. And so -1 times x over x plus 2 times 2 times x plus 2. When we distribute, those x plus 2's cancel. And maybe I'll write it this time, but I normally wouldn't write this step out. So let me just distribute that. If it helps you to look at it with a 1 over it, under it, then do that. And then plus, we have this 1/2 all times this 2 times x plus 2. And then the denominator, we have that x and all times the 2 times x plus 2. So notice our fractions cancel. The x plus 2 here cancels with this x plus 2. And so all we're left with in that numerator for that first piece is -1 times 2. So let me just carry down my limit and do that now. So I have this -1 times this 2 that's left, so that's -2. Plus, so notice over here, our 2's cancel. So we have a 2 in the numerator, 2 in the denominator, those go away. So all I'm left with is this 1 times that parentheses x plus 2. So all we're left with is x plus 2. If there was a number out here, I would have to distribute. I don't have a number out there, and this is plus, so I could really technically drop these parentheses right now if I want. So the trick here is actually not to expand it on the denominator in our case. If we do, we're going to find out later, we're going to actually have to go back and factor it. So we'd have to undo what we did. So I'm going to rewrite this as 2x times x plus 2. Let's simplify our numerator by combining like terms. So I have a -2 plus x plus 2, -2 and 2 cancel. So we're just left with x in the numerator, all over 2 times x times the quantity x plus 2. And so notice after we've simplified this, we have a common factor in the numerator and denominator of x. And so those go away. And so we are left in the numerator. Well, if I get rid of everything in the numerator, I really didn't. There's still a factor of 1 there. So I have a 1 in the numerator all over 2 times that quantity x plus 2. So now when we go in and do direct substitution, notice we're not going to get 0 over 0. So we're going to go in wherever we see an x. We're going to replace it with 0 and then simplify. So I have 1 all over 2 times the quantity 0 plus 2. So really that's 1 all over 2 times 2, which is 1/4. Okay, so there's an example of limits dealing with complex fractions and getting it a form of an indeterminate form and going back and manipulating it.